Welcome pre-cal students to class today. Hope you guys are doing well. Hope you're ready to learn some math. First of all, there will be a test on Monday, so please make sure you're aware of that. If you're not going to be able to make it, I would like to know no later than Sunday. Your integrity sheets are due that day. You will hand me a sheet of paper with everything written down that you've done, and you cannot do more work on those once you walk into my house Monday, okay? Tests really need to be turned in. I had one student stop by and get some help. Two other students have yet to get back with me on their tests. So please be doing that and please take care of that, okay? All right, very good. Let's do a quick little review. Now, before I do a quick little review, I want to be clear that everything we've covered this week is not going to be on this review, so don't think this is everything you need to know. I'm just doing a little review so your brain stays fresh. If you've noticed I've been doing this a little more and more, and so let's do this really quickly, and it will be quick, and then we'll get into today's notes. Okay, if I ask you to write vector CF in component form and then find the magnitude, C is first, so this is your initial point. F is second, this is your terminal point. Do you remember what to do? You take your terminal point minus your initial point, and so it would be 1, 5, which is your terminal point, minus your initial point. Remember, I'm not teaching, I'm reviewing, so I'm going fast. 1 minus a negative 4 would be 5. 5 minus a negative 3 would be 8. And then we put arrows like this, and that denotes the fact that this is a vector in component form. Now let's find the magnitude. Well, we square the 5, we square the 8, we add them together and take the square root of them. So 25 plus 64 square root of 89. That cannot be simplified. Okay, what about dot product of vectors? I'm not going to do all three of these. We'll do this one right here. Let's do V times W. Actually, let's do U times W. So here's U. Here's W. Let's take the dot product. Okay. First number times first number gives you a negative 6. Second number times second number gives you a negative 5. And you add those two numbers together, and you would get a negative 11. So when you take the dot product of two vectors, you get out a number like that. Find a unit vector going the same direction. Okay, we know we're over 6 and up 7, so here's my triangle. There we go. And actually, to be honest with you, I apologize for putting that up there. I don't know why I did that. If we're trying to find a unit vector going the same direction, there's no need to draw the graph at all. There's a formula that I taught you. And the formula is simply this. We'll call it vector V. You take vector V and you divide it by the magnitude. So that's the formula I taught you guys. So let's find the magnitude of this vector very quickly. We're going to square the 6. We're going to square the 7. And then add them and take the square root. That's Pythagorean's theorem. 36 plus 49. And that would be 85. So the square root of 85 is the magnitude of this vector. So what you do to find a unit vector that's going the same direction as this vector, you take each one of these numbers, and like the formula says, you divide it by the magnitude. So 6 over square root of 85, 7 over square root of 85. There, you just found a unit vector going the same direction as this vector. All right, now, what if I asked you to, let me see what's next here. I should have wrote down the instructions. Okay, what if I asked you to write this vector as a linear combination? As a linear combination. Well, remember, you can never write a vector as a linear combination unless you first write it in component form. So this is my initial point. This is my terminal point. I'm going to take my terminal point 5, 7 minus my initial point, which is 1, 5. So I'll kind of cross that off. And we're going to get out this right here. 5 minus 1 is 4. 7 minus 5 is 2. So there. You took CF and you wrote it in component form. And now remember how easy it is to write this as a linear combination? 4i plus 2j. All that you do is take these two numbers, put an I with the first number, a J with the second number, and make sure you put a positive or a negative sign here depending on whatever the sign of the second number is. I'm not going to do all of these, but let's take a look at 2u plus w. It would be 2 times u, and then you add w. So if I took 2 times u, we can do that in our head. 2 times u, that means 2 times both of these. I would have 4i plus 6j. 2 times 2 is 4, 2 times 3 is 6. And then I'm going to add to it w, which is I plus 8j. So let's add these two together. Well, I plus I, don't forget there's a 1 right here. I plus I would be 5i. 6 plus 8 would be 14. And I'm not sure why I put a j here. This should be an I, obviously. There we go. 5i plus 14j. Okay, so a little review there on doing some work with vectors written as a linear combination. If a vector has a direction angle of this, find the unit vector. Remember, we rotate 225 degrees and draw our triangle. That would be 45 degrees right here. And if you're looking for a unit vector, that really means the triangle that you're going to have, we'll say it stops right here, is going to have a length of 1, because a unit vector always has a length of 1. There we go. So if we're going to find the vector that has a length of 1 going this direction here, all that we need is our x and our y, and then we'll have component form. We'll have an x number here and a y number here. How do you find x? Well, it's going to be cosine of 45 equals adjacent over hypotenuse, and this is how you find the y, sine of y. That's incorrect. Sine of 45 equals y over 1. Now go ahead and multiply both sides by 1, and you're left with a cosine of 45 equals x. Multiply both sides by 1, and you're left with the sine of 45 equals x. I'm going to really quickly draw a 45, 45 triangle. It's 1, 1, square root of 2. So let's see here. If I put a 45 degrees here, cosine of 45 would be square root of 2 over 2 equals x, and sine of 45 is also square root of 2 over 2 equals y. This should be a y right here, like it was right here. Okay, so that means my x value going, I'm going to put the answer right up here, guys. Now watch this. My x value going this way is going to the left, so I know it's going to be a negative square root of 2 over 2. And then I know my value is going down right here, so it's going to be a negative square root of 2 over 2. So there we go. We have just found a vector that has this direction and has a length of 1, or a magnitude of 1. All right. Now, really it's going to be the exact same thing again. Let me see what's next here. We're going to find a unit vector. I'm trying to think. I should have wrote the directions down. I apologize, guys. That's my fault. I'm just trying to think what we were going to do here. Find the angle between the vectors. Give me just 10 seconds to think without looking this up. Let's see. We've already found the unit vector. Let's find the direction angle. Let's find the direction angle and the magnitude of this, okay? The direction angle and the magnitude is what I'm pretty sure they wanted us to do. So if I asked you to find the direction angle and the magnitude of this vector, first of all, we know that we're at -2 and -8, so I'm going to draw my triangle really big down here, okay? And I know this is 2, and I know this is 8. So all that I have to do to find my direction angle is find this little angle right here. So I can easily say tangent of my unknown angle is opposite over adjacent. So grabbing your calculator, of course, second tangent 8 divided by 2 gives you 76 degrees. So I know this angle right here is 76. Now if I rotate 180 plus 75, I'm going to get 256 degrees right here to here, okay? So I know my direction angle is 256 degrees. So I just found that, all right? And of course, this up here is a totally different problem. Let's get rid of that. There, I found my direction angle. Now the magnitude, of course, you know how to do that. We square the -2. We square the -8. We add them together and take the square root. So it would be 4 plus 64, which is the square root of 68. And the square root of 68 is the same thing as 4 times 17. 4 times 17 is 68. Cross off the 4, and the square root of 4 is 2, so put a 2 on the outside, and you're left with square root of 17. So there's the magnitude, okay? And again, I'm going fast, but this is review. We've done all of this. These are actual problems taken off of your notes that you did a couple days ago, okay? So this is all review. And then find the angle between these two vectors. Remember, there's a formula. You take one vector times the other vector over the magnitude of one times the magnitude of the other. And of course, off to the side here is cosine theta equals. Okay, well, we can find the numerator pretty quickly. A vector times a vector. You take first number times first number, that's a -12. Second number times second number, that's a +14. Add those together and you get 2. So we know the top of the denominator, the top of the fraction, excuse me, is 2. Now, for the bottom of the fraction, it looks like we're looking for the magnitude of u. And I guess we'll call this u and this v, the magnitude of u. So we square the 3, we square the 7, we add them together and take the square root. 3 times 3 is 9, 7 times 7 is 49. 49 plus 9 is 58. I don't worry about reducing that because we're just going to multiply it anyways in just a second, so don't worry about that. So square root of 58, and then the magnitude of v would be, well, we square the -4, we square the 2, and we add them together and take the square root. Obviously, 4 times 4 is 16, 2 times 2 is 4, square root of 20. So I'm going to come down here and write the square root of 20. Okay? Now, my suggestion to you is I would first work out the denominator, which I'm doing right now, and I would type in the square root of 58 times the square root of 20 and get a decimal for your denominator. So I'm going to cross this off right here, and I'm going to go ahead and put 34.05877273. Now, I'm going to go ahead and put cosine of theta equals, now I'm going to divide this using my calculator, 2 divided by this decimal number. And you should get out something like 0.058722022. And now we're looking for an angle, so second cosine of that decimal, and you will get 86.6. So I'm going to go ahead and say 87 degrees. Okay, that's a quick review of some stuff we've learned this week. Now, go ahead and write this in your notes if you would, please. Today's date is the 5th, and we're looking at vector word problems, and today's date is the 5th. Let me grab a quick drink here. Vector word problems. I would like to give a little bit of a explanation. The word problems we're going to be looking at today are really difficult. You know what, men? Don't turn me off or shut me down. Listen, okay? All that I ask is that you listen well and copy down the steps. I will only give you one of these on your test. I will make it very similar to the ones we were looking at today. I will also grade this problem on your upcoming test very graciously. Well, Mr. Earhart, it sounds like a waste of time to me if that's how you're going to handle it. Well, guys, first of all, it is very important that you're introduced to these types of force problems. Force using vectors. You need to go to college having seen these so you're at least familiar with them. Some of you three will understand them, some of you three might not. Maybe all three of you will. They're not so hard that you can't grasp it. It's just a lot of steps and really long, okay, and a lot of algebra worked into this. Now, again, don't shut me off, please. I want you to work very hard today. Let me explain to you what else I've done, okay? I'll go ahead and show you what I've done. Let me get my mouse, let me get my pen here working. Today's video is going to be very long. maybe over an hour, maybe not, but you have no homework. No homework. We're going to look at 2 of these problems, and I'll give you a couple if you want to practice on your own. It's up to you, okay? Now, look how I've done the notes today. I have everything written down. All I have to do is keep hitting the forward button. And I did that so you would not be sitting there waiting for me to write stuff down. I'm not bragging, but this took a lot of time, but I did it for you guys because I knew it would make the class be a little easier. Number 2, what that does mean though is I'll go a little faster than usual, so you will have to probably pause the video a lot, which is okay. I mean, I think you guys would rather pause the video than sit there and wait for me, and I have to catch up to you. At least you can pause it and then move on, okay? So that's how I've done the video today, and I think we can learn a lot and accomplish a lot, and I hope that you'll find these problems really, really cool. Okay, but you're going to have to work hard. You're going to have to take some good notes. We're going to do 2 problems and then we'll be finished. Okay, all right, here we go. I would like you to go ahead and turn your books to page 665. I want to look at example number 14. Please turn your books at this time to page 665 and let's take a look at example 14. Now example 14 says this: you have a 350-pound block suspended by 2 cables. At point A, there are 3 forces acting on W. The block pulling down and R and S are pulling upward and outward. Find the tension in each cable. Now I'm going to break this down in multiple steps for you, so please listen. The first thing you always want to do with these types of problems is you want to get a picture of the problem drawn on a coordinate plane. Let me show you what I mean, okay? First of all, here's the picture in the book. Now watch carefully. Here's the 2 metal rods. They've got a dotted line going across like this, okay? And here's your box hanging down right here, and here's 1 cable going up and 1 cable coming down like this. Here's your 2 cables. Now, how did I get this picture over here? Oh, students, if you'll listen, I can explain it. Please listen to me. Let me put a 350 here. It's very important. Okay? Now, you want the point where all 3 cables are touching. So here's this cable comes down, touches here, this cable touches here, and this cable touches here. And see that big point right here that I'm circling in black, this point right here? You want that point to always go right at your origin, right here at 0, 0. So that's number 1. Got that? Wherever. And by the way, we're going to do some problems where the cables are coming from different directions. All that you have to remember is always pick up this point where all the forces are acting on that 1 point and put that at the origin. That's very, very important. Okay, students? So I've done that. And notice what I did. I admitted I do not know the magnitude or the length of this vector right here, so I left it blank. Notice I left this one blank. Notice I left this one. Oh, I didn't leave this one blank. This one I knew was 350. Now I know in the picture they had a little short little cable there. I went ahead and drew it longer so we could see more of it. So the first thing you want to do is always get a picture. Does that make sense? I hope it does. You want to get a picture, and you always put this intersection point at the origin. Because the book used R, S, and W for their vectors, that's what I used. You could have used A, B, C, X, Y, Z, whatever you want to use. I used R, S, W, but do give your vectors a name. You will want to give your vectors a name. Got it? Okay, moving on. Next, you need to understand this. In this type of a problem, when you take all 3 of your forces, vector R, vector S, and vector W, they should all cancel out, equaling 0. Or in other words, all of the weight is not equally distributed, but distributed in such a way that each vector is doing its part. You got 350 going down, this vector going up and outward, this one going up and to the left. When you add all 3 of these vectors together, you should get 0. And that's the premise of our entire problem right there. That's our goal, if you will. That's our goal. To find out what S is and to find out what W is. We already know what the magnitude of R is, remember? 350, okay? Our goal is so that all 3 vectors, when you add them together, equal 0. And the only way we can do that is if we find the vector R and find the vector S. Okay, students? So that's our goal. All 3 vectors should add up to 0. Now, I went ahead and wrote out my vectors. I want you to listen as you're copying these down. First of all, the reason I wrote my vectors with direction angles is I knew nothing else about them. Guys, I don't know how far over the point it is. Let's talk about R for a second. I don't know how far over it is. I don't know how far up it is. I don't know the length of the magnet. The only thing I know about this vector is that it has a direction angle of 125. Now, how did I get that? Well, remember, direction angles always start here in the x-axis, and they always rotate to the vector or to the hypotenuse, however you want to say it. So if this is 55 degrees, then this is 125 degrees. So that's why I put cosine of 125 I plus sine of 125 j. That's like writing this as a linear combination, okay? Now, notice on the outside is my magnitude of r, or in other words, the length of r. Now, later on, I'm going to drop these lines because they're really a pain, but do understand this is the length of r out here. And that's how, remember, we did this in the last lesson. We had vectors that look like this. We had a 5, and then this, and then we had cosine of some angle, 25i plus, if you're all caught up on your videos, you'll remember this. And I said to you guys, well, this is so easy. What's the direction angle of this vector? 25. What's the magnitude of this vector? 5. It was that easy because everything was written out for you right there. So that's all that we're doing is we're writing these vectors with direction angles and their magnitude, which we don't know, so we're calling it r. Same thing with s. Do you see what I've done here? I started here and I rotated up, and that would be 37 degrees. So the magnitude of s, which I don't know, on the outside, on the inside, cosine of 37i plus sine of 37i. Now let's go to w. W is a little nicer because we know the length is 350. So with w, I start here and I rotate all the way around, and that gives me 270 degrees. Notice on the outside, I did not put the magnitude of w like this because I know the magnitude of w is 350. So I went ahead and put 350. All right. Now I went ahead and went a step further. We know that if you use your calculator, you'll see that I'm right. Okay. The cosine of 270 is 0. So I have 0i. And the sine of 270 is negative 1j. Okay, so the cosine of 270 is 0, so 0i. The sine of 270 is negative 1, so negative 1j. And then I took my 350 on the outside, and I multiplied it through. 350 times 0 is this. 350 times negative 1 is this. So there's my vector w. Now again, I didn't say this was going to be easy. I told you it's going to be hard. Let me grab a drink here while you're digesting all this. But that is what you want to do next. You want to draw a picture. You want to draw a picture and then write out your 4 vectors. Really, I don't need this one now. I just wanted to show you where I got this from. So there's your 3 vectors, okay? Now here's what we're going to do next. I did nothing here. Look, I just picked up, all I did was pick up this whole mess right here, and I put it right here. Okay, so I've done nothing else. Now don't forget, our goal is to find s and r so that when you add all 3 vectors together you get 0. Please don't forget that. Okay, so I'm going to start off by saying I want r plus s plus w equals 0. So what can I substitute for r? Well, this whole big expression, right? R equals, what can I substitute for s? This whole big expression right here. And what can I substitute for w? This expression right here. So that's what I'm going to do. So here's my r. I put it right here, this whole expression. I substituted my s in from right up here, and this is my whole expression. And then notice here for w, I didn't put the 0i, there's no need, I just put negative 350j. Now we're going to talk about this right here in just a second, okay? So hopefully everybody sees what I've done there, okay? I realize this is my foundation to the whole problem, so I made some substitutions for r, s, and w. Now, remember, your vectors over here are written in i's and j's. Once we simplify them down, we'll have i's and j's. So when you're done adding all of this together over here, you better get 0i plus 0j, which is the same thing as the 0 vector, okay? And that's why I took all of this and I set it equal to 0i plus 0j. Remember, you want to get a 0 over here, or you want all of your vectors to cancel out. Well, Mr. Earhart, why 0i plus 0j? Well, I mean, I guess I could have put a 0, but it's a lot easier if we realize this whole side is going to break down to 0i and 0j, okay? All right, and again, I told you it's not easy, but you can do this if you'll listen and take notes. Now, I'm not bragging, but I've written all this stuff out. It took me hours, literally last night, to do this step by step to get all this up here for you. And so, just do the best you can. Listen, take some notes, and back it up if you're a little confused, and listen to put different parts again if you need to. Now, what'd you do here, Mr. Hart? Well, let me show you. Isn't this r outside the bracket here? So could I not multiply my r through? So r times cosine, r cosine, r times sine, r sine. No big deal. Multiply your s through. S times cosine, s cosine, s times sine, s sine. No big deal. And I brought all this down. That's probably the easiest. That's probably the easiest step out of the whole problem. Okay. Now, this is going to get a little tough now, but if you'll hang with me, I think you'll see what I'm going to do. I decided to put all of my I terms first, because notice over here my I term is first. See that? I, 0I. Then I put all of my J terms next. There were 3 of those, 1, 2, 3, because my J term is second over here. So I moved some terms around, no big deal. I mean, I took this I term here. That's not an I term. I took this I term here and I brought it over here. I took this J term here and I brought it over here, right here. So I just moved some terms around so that my I terms were side by side and my J terms were side by side. That's easy enough, isn't it? Sure it is. And then watch what I do next. I factor out an I. Now you're used to this. When I factor something out, watch carefully please. If I had 2x plus 6 and you factored out a 2, like this, you're used to putting the 2 out front. But there's nothing wrong with putting the 2 over here either. There's nothing wrong with that. You just factor it to the right. And that's what I did. You know why I did that? Because I have 0 and then an I to the right and then a 0 and a J to the right. So I factored out an I. Both of these terms have an I and I pulled it out to the right. All 3 of these terms have a J, so I pulled out a J. Okay? All right. Now, I did nothing here. I just cut and pasted this step up here so we'd have more room, so nothing new. Now, let me get a drink here. Now, let's do this. Can I show you something, please? Do you not want this whole side of the equation right here equal to this whole side? Is that not your goal? This is so cool. Watch what I'm going to show you here. So if you truly want both sides to be equal, do you see this entire thing right here, this whole thing right here, this whole thing right next to the I? Do you see that? What's next to the I over here? A 0. If I could get this whole group right here to become a 0, then I would have 0I. And see this whole group right here next to the J? See that whole group right next to the J? What do I want next to my J over here? Isn't it a 0? So if I could make this whole group here become a 0, then I would have 0J. So that's my goal. I want to make sure this whole expression here becomes a 0, and I want to make sure this whole expression here becomes a 0. So here's how I'm going to do that. I'm going to take this expression right here, and I'm going to set it equal to what? 0. And I'm going to take this expression here, and I'm going to set it equal to what? 0. Cool. Okay? Now, here's where it gets a little tough, and I feel your pain, but I mean, it is what it is. It's supposed to be pre-calc. And again, I'm going to be very gracious when I grade these. I've done all the work for you. I'm not giving you a lot of homework over it. I want you to be introduced to these problems and just see if you can't do it, 1 or 2 of these on your own in the future. Okay? Now, here we go. Notice I have 2 unknowns in this equation, an R and a S. Notice I have 2 unknowns over here, an R and a S. So what I'm going to do, and you could do this many ways, okay? I'm going to come to this problem here, and I'm going to get R by itself. And when I get R by itself, I can then take that expression and substitute it in for R over here. Let me show you what I mean. Take some good notes and watch. First of all, if I want to get R all by itself, I must take this term here, right here, S cosine 37, and bring it over to the other side. And when I do, it becomes a negative S cosine 37. Now, what's still with the R that you want to get rid of? This. And they're multiplying, right? R times cosine 125. So I'm going to divide both sides by the cosine of 125. So it looks like this. Okay, I divided both sides by the cosine of 125. So now I know what r equals. Do you see that okay? Now I know what r equals. So what is stopping me, and the answer is nothing, what is stopping me from picking this expression up right here, this r expression, and putting it in for r right here? Nothing. I can do that. I mean, that's what r equals. R equals this. So look what I did. I did it in red for you so you could see it, and I probably should have put this in red also just for emphasis so you could see what I'm doing. So here's my r, and I substituted this expression in for r right here. Then I brought this down, I brought this down, I brought this and this, brought everything down. Well, Mr. Earhart, does that really help? Oh, it helps so much. Look at your unknowns. All of your unknowns, this is the only unknown you have. You have an s and an s. So you don't have an r anymore. All that you have is s, and we can solve this equation for s now. I didn't say it would be easy, but we can do it. Now, first of all, do you see what I've done here? See this r? This r is gone, and in place of it, I substituted this because r equals this, okay? Now, we've got to start solving this equation. The first thing that I can see is these two are being multiplied together. So let's go ahead and put this over what? Over 1, and let's multiply these together. We're going to simplify here a little bit. So if I do that correctly, I did nothing new. Don't freak out. This is the same problem, just copied over. So I'm going to multiply these two together, like I said, and we get this right here. S cosine 37 times sine of 125 is this, and of course there's a 1 right here. Cosine 125 times 1 is cosine 125 plus this. Now, do you know what I'm going to do next? I do not like fractions, like most students don't. So I'm going to multiply this entire equation by my denominator. You're allowed to do that as long as you do it to every term. This is one term right here. So I'm going to multiply this term by this. I'm going to multiply this term by this. I'm going to multiply negative 350 by this. Let me go back a page real quick here. Okay, so I'm multiplying everything by cosine of 125. Okay, let's watch what happens. Cosine of 125 over 1 times this. Your cosine of 125 would cancel out with this, so you're left with just this. Let's see what it looks like. So you're left with just this. Notice my s sine of 37 has a cosine of 125, and my negative 350 has a cosine of 125. And 0 times cosine of 125 is just 0. Mr. Earhart, have you really done a whole lot of good here? Yeah, I have. Look at all your terms that have an s. This term has an s. Here's a plus sign. This term has an s. This term does not. So I'm going to take the term that does not have an s, and I'm going to move it to the other side. I will show you why in a second. So there, I brought the negative 350 over cosine 125. Now, this term has an s, and this term has an s. So why not factor out an s? That makes sense to me. Pull out an s. So if I factor out my s, I'm left with negative cosine sine plus sine cosine 125 equals this. Now, I factored out an s, and of course, so the s is multiplying times this parentheses. So students, let me see what's next here. That's what I thought. So why could I not divide both sides by this whole expression to get s by itself? Here's the same equation, just copied over, okay? So if I'm going to divide this whole side by, I'm being sloppy here, but you get the idea. If I divide both sides by this, if I divide one side by this, I've got to divide this side by the same thing. What do I come up with? This right here. I'm left with s because I divided this side by itself, canceled it out, and I divided this side by this expression. So there we go. Now be really careful with your calculators here. I mean, really, really be careful. If I were you, I would type this into your... Let me see something here real quick. I would type this into the numerator into your calculator and get out a big decimal. Then I would type this into your calculator and get out a big decimal, and I would divide the two decimals. You'll get I rounded this, it's approximately. You will get out approximately 201 for s. So you have found the magnitude of s. Now, we're halfway done, but the rest of it's really, really easy. Remember earlier in this problem, look back in your notes, and earlier in this problem you will find a page where we got r all by itself. Remember that? Well, if I know that s equals 201, then what's stopping me from putting 201 for s right here and then typing that into my calculator, and I'll know what r equals? Well, the answer is nothing is stopping me. So here's s, I put 201, so negative 201. And if you type that into your calculator correctly, you will get out 280. So there, we're done. You found the force of r. Okay? Now, let's take a look at our beginning picture. Here's our beginning picture. Okay? This is what we started off with. We knew this force here was 350. And now we know S has a force or a magnitude or a length of 201 pounds. I believe it was in pounds, wasn't it? I hope it was. If not, we're going to pretend it was. And R has a force of 280 pounds. So now you know how much tension to put on each cable to hold this this weight of 350. You don't think that's an important engineering problem? Sure it is. From whether you're riding a roller coaster or riding a ride at an amusement park to a warehouse, moving things, whatever, okay? This is very, very important, all right? It's not been easy, but at least I've introduced you to it. Now, do you have homework today? No. So if this video goes a little longer, you're done when it's over, okay? So just relax, and let's do one more problem, and then we'll be finished, okay? I would like you to turn in your books to page... I'm surprised I didn't write this down. I thought I did. Page 668. Please turn your books to page 668 and take a look at number 85. Number 85. Now, notice here, the picture looks like this. Here's a piece of wood or metal going down, and then we have piece of metal coming this way, and then a cable coming down that's hitting here, and then we have a 150-pound box like this. Do you see that? You should see that in your book. Now here's the question I have for you. Mr. Earhart, how do you draw this on a coordinate plane? Well, I told you in the last problem, you're looking for the point where all three cables, or whatever's holding the box up, intersect. Isn't that right here? You've got this cable coming down. It's connecting here. You have this bar coming out. It's connecting here. And you have this weight coming down. It's connecting here. So you pick up your picture and you draw it in such a way that this point right here that I'm highlighting over and over falls right at the origin. Okay? So if that was the case, let's see how Mr. Earhart did. Maybe I did pretty well, maybe I didn't. Okay, let's see. Erase this and erase this. And I should be able to pick up this thing right here and move it over, and this point right here that my mouse is on, that point right there should fall right on the origin. Pretty close. I mean, it's not perfect, but you get the idea. That's what I did. Okay? So I hope that makes sense. That's the first thing you have to do, is you have to move your item over in such a way that this point here falls at the origin. Now let's continue on. Notice I put the angles in there. And this should not be degrees. I'm not sure why I put a degree symbol here, but let's get rid of it. If you see that from now on, just ignore it. That should not be there. It's a length of 150, or a magnitude or a force of 150. Then we have two vectors going to the left, and we know we have 42 degrees right here. If you look in the picture in the book, you'll see there's a 42 degrees right here. All right, now we're going to label our vectors, of course. R, S, and W. You could have used any order you wanted. I'm just trying to stick with the book's example. And we know, now that we've given our three vectors a name, we know when we take R plus S plus W, they have to equal 0. They have to cancel out. There has to be 0 force, because we're trying to balance it out so this thing can hang without fear of it dropping. Okay, so here we go. The first thing we're going to do is we're going to write our three vectors. Remember, vector R. We know that vector R rotates here 180 degrees, and we do not know the length. Now, I did not put the bars this time around R, okay? If there was a real technical math teacher watching this, he would be upset, but I'm just trying to make it less jumbled up. So here's my magnitude of R, that means the length of R, and then cosine of my angle I plus sine of my angle J. That's my direction angle, okay? Now, let's take a look at S. For S, we rotate from here to here, okay? And when we do that, if this is 42 degrees, we're left over with 138. So the length of S times, and then cosine 138, sine of 138. Now let's look at our W vector. obviously we're going to start right here, and we're going to rotate to the vector, and that's going to be 270 degrees. Notice I don't put a W here because I know the actual force or the actual length or magnitude is 150. So 150 cosine of 270 plus sine of 270j. All right. So remember, cosine of 270 is 0i, and then sine of 270 is negative 1j. So when you take 150 and multiply it through, 150 times 0 is 0, 150 times negative 1 is negative 150. Okay. So you've written out your three vectors. We no longer need this one. It's gone. We're just going to use these three vectors. Let me get a drink here. So what I did then, remember, I have r plus s plus w. So I'm going to pick up r and put it right here. I'm going to pick up s and I'm going to put it right here, and I'm going to pick up W, and I'm going to put W right here. Okay, so if I do that correctly, we will get this right here. Okay, now remember, after I've added R plus S plus W, over here I do always want to put 0i plus 0j, because that's your goal. Your goal is when you add all of these together to get out the 0 vector, 0i plus 0j. Now again, I'm well aware of the fact that I'm going faster than you can write, but I would rather do that and you can pause the video than you trying to speed me up. So I'm going to move on, okay? Now, after I've done this, to me it makes total sense that I can take my r and multiply it through. So we're going to simplify. R times this gives me r cosine, r sine. Take your s and multiply it through. S times cosine, s times sine. So that makes pretty good sense to me, okay? Now, do you remember what we did next after that? We wanted to get all of our I term first and our j term second. So, I'm sorry I keep coughing, guys, excuse me. Okay, so what I did next is, notice I moved my I term right here to right here, and I picked up my j term and I put it here. So basically these two just swap places right here, okay? And now all of my I terms come first, there's two of them, and all of my j terms come last, there's three of them. Okay? Now remember what to do next. I did that so I could factor out an I. So I pulled an I out, and I'm left with this right here. I then pulled a j out of these three terms, and when I did, I'm left with this right here. Okay? Now, remember, what do you want? If you want these two sides, the left side and the right side, to be equal, what do you want to be in front of this I? You want a 0. So what do you want this whole expression right here to become? You want it to become a 0, so you have 0i. And you want a 0 in front of the j, so in front of this j right here to the left of the j, you really would like to have a 0. You want to have 0i plus 0j equals 0i plus 0j. So you want this whole group to become a 0, and you want this whole group to become a 0. So because of that, what I said was this. I took this group right here that you want to become a 0, and I set it equal to 0. I took this group here that I wanted to be equal to 0, and I set it equal to 0. Let me get a drink here real quick. And now we have two equations. Now notice this equation has two unknowns, an r and a s, and notice this equation has two unknowns, an r and a s. So what I'm going to have to do is take one of these equations, solve them for r, or solve them for s, whatever, and then go back and substitute that in. I have chosen to solve this for r like I did in the last problem. So I did nothing here except just copy those two equations over, and here we go. If we're going to get r by itself, the first thing I need to do is move this point over and make it negative. Okay, so there we go. I brought the s cosine over and made it negative. Now next, if I want to get r by itself, I've got to divide both sides by cosine of 180. All right, and these will cancel out. So there we go. You're left with this right here. Now that's what r equals. So now I can pick this up and I can put it in for r over here. Okay? So that's what I did. Here's my r. This r is now gone. And in place of that I put this. And now we're ready to do the exact same thing we did in the other problem. Okay? Notice I have an s here and an s here. The only unknown that I have in this whole entire equation is s. So the first thing I'm going to do is I notice I have two expressions being multiplied. So I'm going to multiply these together. I'm going to put this over a 1, and I'm going to multiply these two expressions together. Top times the top, bottom times the bottom. Now if you do that correctly, you'll get this for your numerator and this for your denominator. And I brought this down. Next, remember what I told you guys, I don't like having fractions. I don't like this cosine of 180, okay? Do not like to have that cosine of 180. So I'm going to multiply every term. I'm going to multiply every term in this entire equation by cosine of 180 over 1. Alright, so if I multiply this term by cosine of 180, this would cancel with this, leaving you with just this. Then I must also multiply cosine of 180 times this term, cosine of 180 times this term, and of course cosine of 180 times 0 is just going to be 0. But if you do all of this correctly, you will end up with this right here. Your cosine of 180 canceled out, so you're left with this right here. And then s sine 138 times cosine of 180, and then 150 times cosine of 180. So there we go. Here's your equation. Now notice this term has an s, and notice this term has an s. Notice this term does not. So I want to get all of my s terms on one side. I'm going to take this term and bring it over to the other side. And oh, okay, that's my fault. I guess I decided to factor out the s first. No big deal, but I would have rather moved this over first, but that's okay. Let's just go ahead and pretend, if we could please. That I moved the negative 150 over and made it positive, okay? I moved this term over right here, made it positive, and then I factored out my s, which is what I was going to do anyway. So now let's continue on, and we have the same thing. All right, now I want to divide. If I want to get s by itself, I'm going to have to divide. Let's see if I can get fancy here. I'll probably just mess everything up really badly here, but not too bad. All right. All right, there we go. Okay, now if I want to get s by itself, would I not divide this side by by this right here, and then also I would divide this side here by this whole expression right here. Now it's not going to fit. Some of it will go off the screen, but you get the point. Sure I would. And if I did that, these would cancel out, and I'd just be left with s equals this big fraction over here. So that's what I did. There we go. S equals this big fraction. Now, again, be very careful with your calculator. I would type this whole thing in first up here and get a decimal. Then I would type this whole thing in and get a decimal, and then divide your two decimals out. And if you do that correctly, you will get approximately 224. Not too bad. We're halfway done, over halfway done, because the rest of it's easy now. So we found the force of vector S, 224. Now remember earlier in the problem, look back in your notes, we had an expression where r was by itself. Well, if I know that s equals 224, then I can cross off this s and squeeze in 224 and then type this into my calculator. So here's my s, and for my s I put a 224. Type this into your calculator and you'll come up with 167. So now you found the force of r. So let's go back to our original drawing. Here we go. Here's r going this way. Its force is 167 pounds. And here's s going this way. Its force is 224 pounds. There, we did it. So we did 2 word problems. It took a good amount of time, but you know what? You have no homework. The review sheet is small because remember, 1 week we had Thanksgiving break, and now we've had this week. Your test only covers 1 week's material. So guys, you should be very thankful to have a test this Monday. Talk about a chance to raise your average. Wherever you're at in this class, A, B, C, D, whatever, this is a chance for you to raise your average, okay? All right, now here's the review sheet. Let's see how many problems this is. This would be 24 divided by 2, 12, 13. This would be 34 17, 18. So you're looking at 31 problems. Usually you're in the mid 40s, so you're looking at 31 problems. That's 15 problems a day. If you want to do 15 today and 15 on Friday, you could have this entire review sheet done. Listen to this. You could have this entire review sheet done when you come into class on Monday and take your test and ask me questions while you're taking this test. All this stuff we did this week was easy, in my opinion. All of it. You could be ready for this test, nail it, go home and have nothing to do except listen to my wonderful, super interesting, great, awesome teaching videos. And yes, I'm being sarcastic. And then also you'll want to study the word problems from today. Now, by the way, if you want some practice on these, write this down. On page 668, you could do the following numbers if you want practice. You could try number 83 for practice. You could try number 84 for practice. And you could try number 86. And by the way, 83 is in the back of the book, okay? But the answers, but 84 is not. So you want the answers to 84? Here's the answer to 84. You'll have two forces. One force is 2,241. The other force is 1,830. Okay, so there. If you want to try 84, you don't have to, but if you want to try 84 on your own, there's the two answers. If you want to try 86 on your own, the two answers would be 168 pounds would be one answer. There's two forces. And then 261. So there you go. Okay. Good luck on these. If you try some, hope you do well. But there's the answers for these. 83 answers are in the back of the book. Okay, this is your review sheet. You know by now you don't have to do it. If you'll do it, I'll give you 5 bonus points, but you must have it done when you walk in my door Monday. Well, I have some questions. Well, you have to at least have tried every single problem on here if you want the 5 bonus points. Okay, call me or email if you have any questions. I hope you're doing okay today, and we will see you guys on Monday, and I will have a review sheet help video up Friday sometime.